Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on January 14, 2026, just yesterday. It introduces DASD-4B thinking, a lightweight open-source model that achieves state-of-the-art performance for its scale, even beating much larger models on math and code benchmarks, despite using only about 450,000 training samples. The paper is titled, Distribution-Aligned Sequence Distillation for Superior Long-CoT Reasoning. And as we'll see later, the efficiency gains here are quite remarkable given the small dataset size. And for those interested in the implementation, the authors have shared their code on GitHub. Check out Hugging Face to find the 4 billion and 30 billion parameter model weights. They even provide usage examples, so you can start testing these models right away. Figure 1 breaks down this performance, highlighting the new model in the orange hatched bars. In the top row, covering the AM24 and AM25 math evaluations, it secures the top spot with scores of roughly 88 and 83%. Moving to the bottom left, the live code bench results show a striking lead, scoring 69.3 compared to the runner-up 60.5. Finally, the GPQA chart on the bottom right confirms strong scientific reasoning, where this 4 billion parameter model even outperforms competitors with 32 billion parameters. So, Figure 2 outlines the pipeline behind those results. It starts at the bottom right, where the teacher model generates training data from questions. Moving left, divergence-aware sampling filters these answers to prioritize cases where the student and teacher differ most, focusing effort exactly where it is needed. Next, the process moves up to temperature-scheduled learning. Here, the model first trains on stable, low-temperature responses for basics, then switches to diverse, high-temperature data. Finally, the mixed policy distillation stage in the top right helps the student recover from errors, producing the final DASD-4B thinking model. Alright, Table 1 quantifies that temperature hypothesis. In the top section, training on high temperature data in the second row beats the low temperature baseline, raising AME 25 scores to roughly 76. But the standout is the last row of this group, the cold start strategy. By initializing with stable data first, the score leaps to 81.3. This even outperforms the third row, which used twice as much data, proving that a smart curriculum matters more than raw volume. Well, Figure 5 visualizes the divergence concept I just mentioned, showing how the team decides which data is actually worth learning. The chart plots sentence probabilities, using background colors to classify each segment. Notice the cyan bands labeled teacher sentences. In these areas, the teacher's blue line stays high, but the student's orange line dips significantly. That gap represents knowledge the student hasn't mastered yet, making those specific sentences the highest priority for training. So, Table 6 brings all these components together for a final head-to-head comparison. The bottom section focuses on models with both open weights and open data. Here, the highlighted last row shows DASD-4B thinking, achieving 88.5 on AME24 and 83.3 on AME25. Now, compare that to the AM Thinking V1 model a few lines up. Even though that competitor is a 32 billion parameter model, the 4 billion parameter student beats it significantly, proving that precise distribution alignment can trump raw scale. Okay, having seen the final performance, Table 7 dissects exactly how much each training stage contributes. The first row sets the baseline with the standard QN3 model, starting at 47.4 on AM25. Adding the low temperature training in the second row delivers the biggest initial boost, jumping massively to 74%, which confirms the value of a stable foundation. Next, the high temperature training in the third row adds diversity, pushing the score further to 83 and notably lifting the coding benchmark, LCB-V5, by nearly 12 points. Finally, the mixed policy distillation in the last row adds the finishing touch, squeezing out consistent gains across all metrics. Wrapping up, 2 takeaways stand out. True distillation requires aligning with the teacher's full probability distribution, not just mimicking correct answers, and a smart curriculum allows compact models to outperform giants 8 times their size. This proves that state-of-the-art reasoning is becoming accessible even on standard hardware. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.